Geiger-Marsden experiment. Rutherford was the first scientist to provide correct description regarding the distribution of positive and negative charges in the atom. The basis of Rutherford's atomic model was the alpha particles scattering experiment. He bombarded a thin gold foil with highly energetic alpha particles and studied the scattering of alpha particles. An alpha particle is a positively charged particle having a mass equal to that of helium particle and positive charge in magnitude equal to twice the charge on an electron. The structure is equal to twice the charge on an electron. This experiment provided vital information regarding the structure of the atom. The experimental arrangement is shown in the figure. When a narrow beam of alpha particles falls on a thin gold foil about 2.1 into 10 to the power of minus 7 meter thick, the alpha particles are scattered in different directions which are detected with the help of an alpha particle detector. The alpha particles scattered by the thin foil in any direction were allowed to fall on a small screen coated with zinc sulfide. A faint flash or scintillation is produced whenever zinc sulfide coated screen is struck by an alpha particle. By rotating the screen to various directions and count the number of scintillations with the help of a microscope, it was possible to estimate the number of alpha particles deflected through any angle from their original direction. The whole arrangement was enclosed in a vacuum chamber to prevent the scattering of alpha particles from air molecules. Experimental observations. Most of the alpha particles were formed to pass through the gold foil without being deviated from their paths. Some alpha particles were found to be deflected through small angles and their angular distribution is fixed. Theta is less than 90 degree. Few alpha particles were found to be scattered at fairly large angles from their initial path and come back. Theta is greater than 90 degree. A very small number of alpha particles, about 1 in 8,000, practically retraced their paths, suffered deflections of nearly 180 degree. The graph between the total number of alpha particles n scattered and the scattering angle theta is shown in the figure. Graph obtained on the assumption that atom has a small, dense, positively charged nucleus.